In this video, I'm going to show you where the trapezoid area formula comes from. Prior to this section, your book is having you take trapezoids and break it up into a rectangle in the middle with triangles on the outside. The formula that we're going to develop doesn't actually require the trapezoid to be isosceles. Remember, an isosceles trapezoid will have two equal sides, you'll have equal base angles, you'll have equal upper base angles. That's not even going to be required for what I'm going to show you. So all you're going to need is the lengths of the two bases and the height of the trapezoid, okay? And here's the trick I'm going to use. Remember when I worked with the area of a triangle, I created a congruent triangle and I made a parallelogram with the two triangles. Same kind of thing here. I'm going to create another congruent trapezoid and I'm going to flip it over, okay? And so I'm going to put that congruent trapezoid right here. So we'll have the longer side that's 6 up here, and we'll have the shorter side that's 4 down here, okay? And this angle is going to be down here, and this angle is going to be up here. We're going to get something that'll look kind of like this. These two angles should be the same. Those two angles should be the same. If you remember from chapter 5, a quadrilateral that has both pairs of opposite angles congruent is a parallelogram, okay? So this shape here is a parallelogram. Well, we know how to find the area of a parallelogram. The area of a parallelogram is just the product of the base and the height, base times height, all right? The base length here is 10. The height, remember, is the altitude. It's not the side lengths here. It's the altitude is 3, okay? The area of that whole big long parallelogram is 30 square units, okay? But remember, that parallelogram is two congruent trapezoids, okay? So that means this one has an area of 15 and that one has an area of 15. In other words, it's half of the area of the parallelogram, okay? Now, I'm gonna tweak this just a little bit. This doesn't quite work the same as the triangle formula because you've got an upper base, you've got a lower base. So I wanna look at what actually happened here, okay? What we really did here to find the area, this whole base, maybe if I call this base 1, let's call this base 1 and I'll call this base 2, okay? This is base 1. That whole base there is base 1 plus base 2, okay? So that's the length of the entire base, base 1 plus base 2, okay? We multiplied by the height, okay, so it's the length of the base, which is base 1 plus base 2. We multiplied by the height, and then because I had two trapezoids, I cut it in half. So I'm going to take half of that result. And that is the trapezoid area formula. Area of a trapezoid is 1/2 the height times base 1 plus base 2, okay? A little bit more complicated formula, but still not too terrible, okay? And just to show you that it works for this particular example, I'm going to write it up here. So half the height times base 1 plus base 2, okay? In this particular example, we go back to the original. Remember, the area is supposed to be 15, okay? We're going to take half the height of 3, and we're going to multiply that by the sum of the bases. The bases were 4 and 6. Okay, so this is going to be half times 3 times 10. Okay, 1/2 of 3 times 10 is in fact equal to 15 square units. Okay, so you can see here that the formula does work out, does give us the same thing. It's a really nice formula to work with. Okay, now you can think about this formula in a couple of different ways. This is what you're going to see in pretty much every textbook. It's what you're going to see on the AP exam, for example, when you use the trapezoidal rule, which is actually a thing that's pretty important in calculus. There are a couple of different ways to think about this. These are all being multiplied. So I can actually change the order here. For example, I can take the height times base 1 plus base 2 and then take half of base 1 plus base 2. I could write it like that, okay? If you notice here, what am I doing? I'm taking the average of the bases, okay? There's actually a term for this. Notice I have one base that has a length of 4, and I have a base that has a length of 6, okay? If I draw a segment through here. If I make this a midpoint and that a midpoint, this segment's going to be parallel to those other two bases. This is called the median of the trapezoid. Turns out that the median is the average of the two bases. So 4 plus 6 divided by 2 is 5. That's the length of the median. So your book also has another formula. I think of this as the average of the bases times the height. When I was a kid, I actually thought of this as kind of being like a rectangle. I couldn't decide, is this my base or is this my base? Hey, we'll just average the two and then we'll multiply by the height and we'll get the area. So notice the average of 4 and 6 is 5. And then if you remember, the height was 3. Okay, 3 times 5 is 15. That would be your area. Okay, your book gives you a little different formula. They say, well, the average of the bases is really the median. Okay, so your book says that the area is also equal to the median times the height. Okay, and again, the formula that I used a lot is that the area is equal to the average of the bases times the height. Okay, again, that's the formula you're going to see in every single geometry book. But your book will use occasionally the formula median times height. They'll sometimes just give you the median. And I always like to think of it as the average of the bases times the height. So just to show you one more example here. So let's say I had a trapezoid, and again, it does not have to be isosceles. It could be something like this. Say I've got one base of 3, and I've got a base of 7, and the height is 4. Okay, traditional formula says take half the height, multiply by the sum of the bases. So add up 3 and 7. So you get 1/2 of 4 times 10. Half of 40 is 20 square units. Okay, great way to do it. Formula gives you the right answer every single time. Okay, but you could also take the median times the height. Okay, the median is going to be the average of 3 and 7, which is 5. The median times the height is also going to give you 20 square units, same area, all right? Or, use the formula I made up when I was a kid, it's the average of the bases. It's half of these two things added together multiplied by the height. What's the average of the bases? Well, the average of the bases is 5. You're taking the average of the bases times the height of 4, and you're still getting 20 square units. So a bunch of different ways to find the areas of trapezoids. And in some cases, you can break it down into a rectangle and triangles. But I think these formulas will make your life a little bit easier. One of the other things you'll occasionally be asked to do is to find missing dimensions, okay? And I do think this formula is typically the best one to use if they ask you to do that. So for example, you might be given a trapezoid that has one height of 4, and maybe you have a base of 8, and let's say that the height is 5, something like that, okay? And maybe they tell you that the area is 30 square units, okay? You should be able to, is that the one I think that's the one I just did earlier, but no, maybe not. Anyway, should be able to fill everything into the formula and just work backwards, okay? So we know what the area is, that's 30, okay? It's equal to half the height, which is 5, times base 1 plus base 2. We have base 1, it's 4, and we don't know base 2, we'll just call that x, okay? So I filled everything in here. I would probably, since I can't take half of 5 without getting a decimal, I would probably double both sides first. So I would multiply this side by 2, multiply that side by 2. 2 times a half is 1, and we get 60 is equal to 5 times 4 plus x, okay? You could distribute 5 through here, or you could just divide both sides by 5, and you'll find out that 12 is equal to 4 plus x. In this case, x is going to equal 8, okay? And hopefully you can see the average of 4 and 8 is 6. 6 times 5 really does give you an area of 30 square units. So again, should be able to take the heights, the height and the bases, put it into the formula and get the area, but you should also be able to work backwards. If you have an area, be able to substitute that into the formula and use the algebra you learned last year to unravel the equation and solve for whatever your missing value is, okay? Forwards and backwards, we need to know how to do both.